Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating debugging saga from the EdgeDB team. They encountered a perplexing issue while porting network I/O code from Python to Rust, specifically within a new HTTP fetch feature using the request library. The problem? Intermittent test failures on ARM64 CI runners, initially appearing as deadlocks. ~person1 greater than, ~person1 greater than.
A deadlock on ARM64 but not x86-64? That's unusual. What were their initial suspicions?
Yeah, very strange. Their first thought was a difference in memory models between Intel and ARM64 architectures. Intel's model is stricter, while ARM's is more weakly ordered, potentially leading to inconsistencies in how memory writes are observed across threads. ~person1 greater than, ~person1 greater than.
So, different memory ordering could cause a deadlock? That's a pretty low-level issue.
Exactly. But it turned out they were wrong. The problem wasn't a deadlock at all. The process had actually crashed, undetected by the test runner. They used AWS's root access to SSH into the ARM64 runner, and, after some initial confusion with Docker containers and process namespaces, found a core dump. ~person1 greater than, ~person1 greater than.
Ah, the classic core dump. So they used GDB to analyze it, right?
They tried, but initially GDB threw a bunch of errors because it couldn't find the necessary shared libraries outside the Docker container. After copying the libraries and setting the correct path in GDB, they got a backtrace, but it pointed to a crash within getenv, in the C standard library, not their Rust code. ~person1 greater than, ~person1 greater than.
Whoa, that's unexpected. Getenv, crashing? That's a pretty fundamental function.
Precisely. The backtrace showed the crash happening deep inside libc, specifically within getenv. The team initially suspected environment variable corruption, but the information wasn't clear enough. Then, a crucial comment pointed them to a blog post about the thread unsafety of setenv and getenv. ~person1 greater than, ~person1 greater than.
So the problem wasn't in their Rust code or even request, but in the interaction between multiple threads and the C standard library's environment variable handling? That's a sneaky bug.
Exactly. The analysis revealed that a race condition existed between threads calling setenv and getenv. A thread modifying the environment using setenv could cause a reallocation of the environment block, leading to a use after free scenario when another thread simultaneously called getenv. The getenv function was trying to access freed memory, causing the crash. ~person1 greater than, ~person1 greater than.
That's incredibly subtle. How did they pinpoint the exact cause?
Through careful examination of the GDB output, they noticed that a register, x20, pointed to an invalid memory location. By comparing the memory around this location with the current environment block, they found that the environment variables SSLCERTFILE and SSLCERTDIR were the point of divergence. These variables were set by OpenSSL a dependency of rust-native-tls, which request uses ~person1 greater than, ~person1 greater than.
So the OpenSSL probe library, which sets environment variables, was the root cause of the race condition? That's a pretty deep dive.
Yes. The solution? They decided to switch from request's rust-native-tls OpenSSL backend to Russell's to avoid the issue. Another option would have been to use Python's GIL to serialize access to the environment variables. But switching backends was deemed simpler. The Rust project is also working on making environment setting functions unsafe in future editions to prevent such issues. ~person1 greater than, ~person1 greater than.
Wow, what a journey. This highlights the complexities of multi-threaded programming and the unexpected ways seemingly unrelated components can interact to cause crashes. A great example of how even safe Rust code can run into problems when interacting with unsafe C libraries.
Absolutely. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into a fascinating debugging story. Until next time, goodbye. ~person1 greater than, ~person1 greater than.
Bye-bye.